Okay, you should remember from GCSE your definitions of sine, cos, and tan from the right angle triangle. The way that many people remember this is by SOHCAHTOA. So we say sine theta is the opposite side over the hypotenuse, cos theta is equal to the adjacent side divided by the hypotenuse, and tan theta is equal to the opposite side divided by the adjacent side. Now we can use these definitions of sine, cos, and tan on two nice triangles. The first one is an equilateral triangle, so that has sides lengths, all sides are equal to 1, and you should remember that all angles are equal to 60 degrees as well. Now if I split this into two right angle triangles, I'm bisecting this angle here of 60 degrees, so I end up with two angles both equal to 30 degrees, and this other angle is a right angle. So from this diagram, I know this length is equal to 0.5 and this length is equal to 0.5, and I can find this length here, let's call that x, by using Pythagoras' theorem. We can say that x squared plus 0.5 squared, or a half squared, is equal to 1 squared. So that means x squared is equal to 1 minus 1 over 4. So x squared is equal to 3 over 4. That means x is equal to root 3 over root 4, which is root 3 over 2. So we can write in place of x in our diagram, root 3 over 2. Now we can use the definition of sine, cos, and tan to find sine, cos, and tan of 60 and 30 degrees. So if we first use this angle here, 60 degrees, we can say that the sine of 60 degrees is equal to our opposite side, which is root 3 over 2, divided by our hypotenuse, which is 1. So the sine of 60 degrees equals root 3 over 2. We can also say the cosine of 60 degrees is equal to our adjacent side, which is a half, divided by our hypotenuse, which is 1. So the cosine of 60 is equal to a half, and we can say that tan of 60 is equal to our opposite side, root 3 over 2, divided by our adjacent side, which is a half. So we can take a common factor of a half out of both top and bottom and cancel those out, and we get tan 60 is equal to root 3. Now we can do the same thing with the angle of 30 degrees as well, and when we do that, let's just move this to the sides. We're looking at this 30 degrees here. So our opposite side is a half, our adjacent side is root 3 over 2. We can say that sine 30 is opposite, which is a half, divided by our hypotenuse, which is 1. So sine 30 degrees is equal to a half. Similarly, cos 30 degrees is going to be the adjacent sides, which is root 3 over 2, divided by our hypotenuse, which is 1. So cos of 30 degrees is root 3 over 2. And tan of 30 degrees is going to be our opposite side, which is a half, divided by our adjacent side, which is root 3 over 2. This simplifies to 1 over root 3. And if we rationalise the denominator there, we end up with root 3 over 3. One more special triangle that we can use to find some nice values of sine, cos and tan, and that is a right angled isosceles triangle with a hypotenuse of 1. So with an isosceles triangle, these two angles are going to be equal to 45 degrees, and our two sides are going to be equal to each other as well. So we can call these x. Now we know from Pythagoras that x squared plus x squared is equal to 1. 1 squared, sorry. So that means that 2x squared equals 1. So x squared equals a half, which means x equals 1 over root 2. So now we can say that sine 45 degrees is our opposite side, 1 over root 2 divided by our hypotenuse, which is 1 over root 2. And if we rationalise the denominator of this, that is root 2 over 2. Similarly, cos of 45 degrees is going to be our adjacent side, which again is 1 over root 2 divided by 1, which gives us the same as sine of 45, root 2 over 2. And tan of 45 degrees is going to be our opposite side, 1 over root 2, divided by our adjacent side, 1 over root 2, which is just equal to 1.